part 2 video for definite integrals and antiderivatives. And we're going to pick up with the definition here. This is the average value for an integral. Sometimes they do call this the mean value, but it's an average value of an integral. So if f is integrable on a to b, its average value on a to b is, you can see AV of f, so that stands for average value. It's 1 over b minus a times the integral. So basically you're going to find the integral like normal and then divide it up depending on what your distance is from a to b. So example 3, find the average value of f of x equals 4 minus x squared on 0 to 3. Does f actually take on this value at some point in the given interval? So we have to both find the average value and then figure out if there is a solution to the average value that is within the interval of 0 to 3. So my average value is 1 over b minus a times the integral from a to b of f of x dx. So that's going to be 1 over 3 minus 0 times the integral from 0 to 3 of 4 minus x squared dx. So we can go through and integrate that. We can actually use fn int as well, so using that option on your calculator. And whenever you use the option on your calculator, you actually end up with the fact that the integral is 3. If we were to integrate 4, that would give us 4x. Integrate the x squared, that's going to be 1/3 x to the 3rd power, and then you plug in the 3 and plug in the 0, but you end up with 3. I saved a little bit of time there because I want to make sure you can work with this. We're going to do some more work with actually taking the antiderivatives whenever we get to 6.4. So my average value is 1. Now it says, does f actually take on this value in the interval? So I want to know, is there some value where 4 minus x squared is equal to 1 that falls in between 0 and 3? So if I go through and solve this, I get x squared is equal to 3, which means x is equal to plus or minus the square root of 3. Well, and if I think about my interval from 0 to 3, I have 2 answers for x where it takes on this value, but the positive version is in that interval 0 to 3. So negative 3 does not fall within that interval, but positive 3, square root of 3, actually does. So this is the official definition for mean value theorem. So we found the average value, but now we actually have the mean value theorem for definite integrals, which says that if you have an interval or a function that's continuous on your interval a to b, there has to be some c value that is equal to the average value. So there has to be some c in that original function that is equal to the average value. So basically what they were asking us in that last example, does it take on that value? It has to. As long as f is a continuous function, it would have to take on that value at least one spot. Up in the top, there's an exploration in your book, the derivative of your integral from a to x of f of t dt is f of x. So basically, if you take the derivative of an integral, they undo each other, and you're just left with the function. You would put in the x that's up on the top there. We are going to expand upon that more. That's actually part of the fundamental theorem of calculus, so that's going to come up in 6.4. But this exploration, this result means that the integral is an antiderivative of f, which we can use in the following way. So if we know that f is an antiderivative of little f, then the integral from a to x of f of t dt is equal to capital F of x plus c, which means, well, if we have from a to a, that would give us f of a plus c. We know that 0 would have to equal f of a plus c, and that means our constant value has to be the negative of f of a. which means that the integral from a to x of my lowercase f of t dt is equal to capital F of x minus capital F of a. This is going to set the scene for the fundamental theorem of calculus, one of the parts of it. There's part 1 and part 2, and depending on which book you're looking in, they switch back and forth between which one's part 1 and which one's part 2. But this is an extremely powerful result. Basically, you would take your antiderivative, you plug in your top piece, you plug in your bottom piece, and you subtract the values that you get. So we are going to use that fact in this example 4, where we are going to find the integral using that formula. So the integral from 0 to pi of sine of x dx. Well, the first thing I have to do is take the antiderivative. The antiderivative of sine of x is going to be negative cosine of x. So my capital F of x is going to be negative cosine of x, and I'm evaluating that from 0 to pi. Now this notation about the evaluating, that's going to make more sense in 6.4 because we're going to be using that a lot more there. So this is equal to negative cosine of pi minus negative cosine of 0. Because we plug in the x term, that's what's on top first, and then plug in the a term that's on the bottom. Well, the cosine of pi is negative 1, so that's a double negative 1. Cosine of 0 is positive 1, but then I have the negative here, so I have a double negative 1 minus negative 1. That value is actually 2. So the integral value, the area under the curve, is equal to 2. So those were some additional ways to use some of the theorems and some of the definitions that we have for integrals. Again, this whole chapter, chapter 6, is really getting into the definite integrals where you have values for a and b. So please go back through and rewatch this video. Make sure you watch the book video because I'm sure they're going to have some helpful insights here as well. And reach out to me if you have any questions at all.